Learn beyond the infinity. Future starts here.
Hello everyone, welcome back to the Quantum Explorer. In today's video, we will learn about time complexity and space complexity in depth, in advance, without any doubts. Remember, in every interview question and in every DSA question, the interviewer asks you to optimize your code and decrease its time complexity to make it very fast. So this concept is very important. Let's begin. First of all, by name, we must understand that time complexity is not equal to real time taken by the system to implement the code. Why? Let's take an example. We have system of two types, system 1 and system 2. System 1 which is an old version system and system 2 which is new version system. In old version system, when we write some amount of code, it might possible. It will take 5 seconds to implement full code. And same code, same line of code in new system, it possible. It will take only 2 seconds. So we cannot say for the system 1 time complexity is 5 or system 2 time complexity is 2, because time complexity must be same for every system and every compiler. Why compiler? Because someone who use VS Code, another one use Replit or Jupyter. So by compiler, time of implementation of code varies. So no one can say that for different compiler time complexity different because time complexity must be same for every system and every compiler. So what is the real meaning of time complexity? Let's understand it. So what is actually time complexity? Simply I can say that time complexity is rate at which time taken by the code, by the compiler to implement the code increases with respect to number of input increases. Rate at which time taken by the compiler increase with respect to the number of input increases. What it means? Let's say an example. We have two system. A system one is old system and system two is new. That's the plot of graph of time taken by the compiler and the number of input. In old system, we give 10 in 20 and 13. This is the number of input and the time taken it is let's say 2, 4, 6, 8. When in old system, when I give input 10, it take 2 seconds. When I give input 20, it will take 4 seconds. When I give input 30, it will get it will take 6 seconds. When I join the line and measure this angle theta, let's say it is equals to x. Theta means the rate at which time taken by the compiler increase when the number of input increases. In new system, when input is 10, 20, 30, time taken will be 1, 2, 3. And when we join it and measure this angle theta, it must equal to x. Means in new system and in old system, when we give same number of input, it might possible it will take different time to implement the code, but rate at which time increases is must be same in any system in any compiler. Now we learn about big O notation. What is big O notation? Big O notation is nothing but a representative way of time complexity. Time complexity represented by this big O sign, and inside the parenthesis we write time taken. Big O notation is nothing but the simple explanatory representation of time complexity. Let's have an example for a code. I write here code for int I is equals to 0, I less than 10, I plus plus, and here I can write C out our symbol name queuing. How this code will implement and how we calculate the time complexity. Time complexity, first of all, we see here how many times this loop will run. Okay, I starts from 0 and I starts from 0 and go up to 10. When I is equals to 0, how many function means how many step it will take. It compares, increment and print. 3 step. When I is equals to 1, compares, increment and then print. 3 step, 3 step. How many times loop will implement it? 10 step. In each loop, there are 3 step. Okay. Total 30. So time complexity for this code will be big O of 30. I hope you understand how to write time complexity. We cannot write time complexity like that in 30, 50, 60 or any integer time. So how we write time complexity? There are rules for write time complexity. Mainly 3 rules. First of all, time complexity always written in worst case. Second rule, avoid constants. And third step, avoid small numbers, smaller terms. What it means, let's take an example and understand. As I told you, we cannot write time complexity like that in this way. So how we can write? First of all, we must write it in generalized way. Why in generalized way? Suppose you make a website or write a code for making a new ML model. So for how many audience you write? You write for only two audience or you write for 1 million or 1 million or crores or 10 million audience? Of course for 1 million. So we must write it for generalize. So for a large number of when the large number of input will given, it will handle it. So that is why we not write like that. So it is the right method to write it. Let's say instead of 10 here write 15. So what is time complexity? Time complexity will be 15 into 3. If I write 100, time complexity will be 100 into 3. For generalize, when I write I less than n, time complexity will be big O parenthesis n into 3. So ultimately, time complexity became 3n. This is the way to represent time complexity. Next, understand these 3 rules to write time complexity. First rule. First rule say this, write in worst case always. There are 3 kind of case. Worst, best and average case. What is that? Let's have an example. In this code, you can see I have write a code when marks is greater than less than 33, it will output will be fail. When marks is greater than 50, output C, and marks is greater than 80, output is A. Output is A grade. So when user give input and marks, let's say marks is 25, then just count how many steps are run in the program. First, compare and then output. Only 2 steps. Let's say when user give input of 60, how many step how many step will be count? Compare false. Here again compare and output 3. Let's say output will be 85. How many step? compare false, compare and output. 1, 2, 3, and 4. 4 step. So, so what is best case? In the first trial, output will be output will be true. This is the best case. What is worst case? Output come at the last number of input, large number of input. This is the worst case. And all other cases, their best case and worst case are called average case. So time complexity will is written in the worst scenario. This is the first rule. Second rule, avoid the constants. Okay, let's take an example. We have time complexity like that 25 and cube plus 33 and square plus 40. This is the time complexity. When you write real world project and real world applications, here n is not like 10, 2, 3, 15. N is like 10 raised to power 5, 10 raised to power 8. So let's say n is 10 raised to power 8 and I write this time complexity 25 into 10 raised to power 8 cube means 8 into 3 24, then 33 n into 16 and then 40. Just imagine 24, this kind of large amount of value, and 14, it can be ignored. 24, 10 raised to power 24, and there is 10 raised to power 16, which means 1 into 10 raised to 1 comparable of 10 raised to power 8. Never. So this also can be ignored. Ultimately, time complexity will be 25 to 10 raised to power 24. And also the constant like 25 here divided by 2, it also be ignored, and ultimate time complexity will be 10 to the power 24. We can ignore the constant like 25 or divided by 1 by 2 or anything. We write time complexity like that. This is exact time complexity and this is approximate time complexity, but in every interview question they will tell you to give time complexity and you will written this. So this is the basic of how we can write time complexity. Let's take an example to write and understand time complexity. Let's say there is a code for it. For int I is equals to 0, I less than 10, I plus plus, and there is another for loop for int j is equals to 0, j less than, let's say here n, here also n, and j plus plus. And here is few lines of code which have time complexity constant, means only one step. So at last when we write time complexity we can ignore it. Okay, so we have task to write the time complexity for this code. How we can write this? Value of I is equals to 1. How many times second loop work? First of all, in second loop value of j becomes 0, 1, 2 up to n. When value of I is equals to 2 second time, also this same situation, until when value of I is equals to n, value of j will be 1, 2, 3 up to n. So inner loop will executed n times. How many times? N times. Whenever whenever outer loop will be executed, inner loop will be also executed. Outer loop executed n times in how many iteration? N iteration. So ultimate time complexity is n square, and we can represent like it this. Big O of n square is the time complexity for this code. Let's say here instead of n, here is here instead of n, here is option of I, here is I. So how time complexity will work? Let's understand it. And the value of I is equals to 1. Second loop will, second loop will be implemented only once. When value of I is equals to 0, second loop will be implemented 0 time. When value of I is 1, second loop will be implemented 1 time. I is equals to 2, second loop implemented 0, 1, 2, 3 times. Here is less than or equal to. So we can write like this. Second loop implemented how many times? Loop will be inner loop. How many time will be inner loop run? First of all, inner loop 1, 0, then plus 1, 2, 3, up to n times. This is the formula of first n natural number. So it can write n into n plus 1 divided by 2. And when we solve it, n square by 2 plus n by 2. According to the rule, we will remove this term and time complexity will become big O of n square by 2. And again, when we ignore constant, time complexity become big O of n square. So this is how we can write time complexity for any given code. Talk about space complexity. As time complexity, first of all, space complexity is not actual space, and it also denoted by big O notation. How? Space complexity is nothing but the summation of auxiliary space and plus input space. What is auxiliary space? Auxiliary space is space taken by compiler to solve the problem. And what is input space? Input space is space taken by memory to store code. Space complexity is basically the sum of auxiliary space and input space. How we write space complexity? Let's take an example. When I declare an array of integer type of size n, I can say that the space complexity of this array will become big O of n. Why? Because it will take in memory it will take n size to solve the problem. Space complexity, we cannot say space complexity like this much MB, this much KB. It must be denoted in big O notation. Let's take an example. We have two numbers and we want to give, in return we want to give summation of these two numbers. So we have two options. First of all, we declare another variable C and we'll give A plus B. And another option, we will manipulate B and return like A plus B is equals to A plus B. This time space complexity for this code is lesser than time complexity for this code, but this code can be not preferable. Why? Because when you are in a company will give you the large number of data set and you are manipulating this data set. This is not the fair way. Instead of it, you must declare another variable or you must make another rows or columns to return require output. So that is why these lines of code will be preferable. This is the all basic about time complexity and space complexity. It will be more clear in when we solve the pattern problems in next video and next further when we solve the different kind of problems and when we understand different kind of complex concept in our DSA journey, we will get more clarity about time complexity and space complexity.